Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 11th. The chapter which we are dealing with is straight lines, and this is exercise number 10.2 which we'll be dealing with over here. Now exercise 10.2 deals with various forms of the equation of straight line, right from the 2-point form, point slope form. Then you move on to the intercept, which is x-intercept, y-intercept, separate forms. Then you move on to the intercept form, which is double intercept form or that matter. And finally, gradually moving on to something called a normal form, x sin alpha plus y, x cos alpha plus y sin alpha is equal to p, that kind of a form. Right. So, questions are based on all of these forms one by one, and we'll be discussing the questions. Let's begin with the first one over here. So in exercises 1 to 8, find the equation of the line which satisfy the given conditions. Okay, write the equation for the x and y axis. Now for x and y axis, it is pretty simple to write the equations. We know the concepts of that of lines which are parallel to the x and y axis, which are very simple lines. Let's suppose if you have this line, for this particular line, if this line passes through this point 2 over here, if this is parallel to the x axis, then you can observe that for all the points lying on this line, you have y coordinate as 2. X coordinate can be anything, but y equals 2. Now this is this particular line. But if this 2 becomes 0, that is if you talk about the x axis. If you talk about the x axis, in this particular case, the x axis, for the x axis, all points will have y coordinate 0. So equation of x axis will be y equals 0. Similarly, the equation of y-axis over here, for y-axis, what do you have? For y-axis, all points will have x coordinate 0, and yes, these are the corresponding equations of x-axis and y-axis. There's a cross over there. X-axis, for x-axis the equation is y equal to 0, and for y-axis the equation is x equal to 0. That's what we have. That's the complete solution of this first question. The second question says that once again, we are supposed to find the equation of line satisfying given conditions, which says passing to the point this with slope this. Okay, so you are given a point and you are given a slope. So we'll use something called point slope form. And what does that form say? If you have a line passing through A, x1 comma y1 and having a slope m, the equation will be y minus y1 is equal to m times x minus x1. And the equation is obtained with the help of slope by writing coordinates of any point P, any random point P on this line in terms of slope. So m of AP is equal to m basically. Y minus y1 upon x minus x1 equal to m, which simplifies to this. This is the equation in point slope form. Now here in this question, what are we given? We are given this point to be minus 4 comma 3 and the slope as 1 by 2. So y minus 3, y minus y1 times slope times x minus x1, which becomes x plus 4 is the equation. Let's simplify this further, and what do we get? This is 2y minus 6 is equal to x plus 4, or which can be done as x minus 2y minus 10 is equal to 0. Bringing everything on the right hand side, x minus 2y, and this will become plus 10, not minus 10. Take care of that. This is the answer for this second part over here. The third question says passing through 0 comma 0 with slope m. Okay, so again you are given a particular point and you are given some slope. So for 0 comma 0 and having slope m, the equation will be y minus y1 is equal to m times x minus x1, which is actually equal to y is equal to mx. So any line passing through origin, will be of this particular form, y is equal to mx. Take care of that and you're good to go for this question, right? That's the solution. The fourth question says passing through 2 comma 2 root 3 and inclined with x axis at an angle of 75 degree. Now inclined at an angle of 75 degree with the x axis, you are given slope, but you are not given the slope directly. You are given inclination on the basis of which you can find the slope, right? And you already have a point over here. Let's say this is point 2 comma 2 root 3. Now this diagram is not to scale, mind you, 2 comma 2 root 3. X axis will be somewhere here for that matter, right? X axis will be somewhere here. This is the x axis, let's suppose. Okay, and inclined with x-axis at an angle of 75 degree. This angle is 75 degree, it is given, right, inclined, right, that's what you have. So m, the slope will be equal to, if this is the slope m, that will be equal to tan 75 degree. And what's the value of tan 75 degree? You should be aware of that. Tan 75 degree is actually 2 plus root 3. This can also be written as, this could also be written as root 3 plus 1 upon root 3 minus 1. If you remember this version, well and good. If you remember this version, it is also good, right? This can be rationalized to give you this, right? The rationalizing the denominator will actually convert this into this particular form. Right? That's what you can do. But this is something which you should remember, okay? In case you don't remember, so how can you find tan 75 degree? Now tan 75 degree can be found with the help of, by writing it as tan 45 degree plus 30 degree as well. This is how you can find this. And you know tan 45 degree, you know tan 30 degree. You can easily find this. This is tan of a plus b, which is tan a plus tan b upon 1 minus tan a tan b, right? Using that, you can find tan 75 degree easily. This is the value of tan 75 degree. What else? You have found the slope, you are given a point, so you can apply the point slope form. Therefore, equation y minus y1 is equal to m times x minus x1 is the form. So where does that take us? This becomes y minus y1 is 2 root 3 is equal to slope, which is 2 plus root 3 times x minus x1, which is x minus 2. This is what you get. This is what you get, right? Let's simplify this further. Y minus 2 root 3 is equal to 2 plus root 3 times x minus 4 minus 2 root 3. You observe minus 2 root 3 will get cancelled from both of these sides, and you get y is equal to 2 plus root 3 times x minus 4. Or you can bring this y also over here. This is the final answer for this question, right? That's the final answer for this question, fourth over here. The fifth question says, intersecting the x-axis at a distance of 3 units to the left of origin with slope minus 2. So you're actually given x-intercept in one way, and you're also given the slope. So intersecting the x-axis at a distance, okay, left or right of origin. So let's draw the coordinate axis first. This is x-axis, this is y-axis. At a distance of 3 units to the left of origin. 3 units to the left of origin, this point will be minus 3, comma 0, right? Slope minus 2. Slope minus 2 would be this kind of a slope, right? This is what you'll have. Since the slope is negative, this will be, the inclination will be greater than 90 degree. So this angle will be greater than 90 degree. That's what you'll have. This is the kind of line that you'll observe. And for equation of line, what do we have? The concept says that if you have this x-intercept as something called h comma 0 and you have slope m, what you can write the equation, you can write the equation as easily in point slope form as y minus 0 is equal to m times x minus h, or which simplifies to y is equal to m times x minus h. This is what you have, right? This is the form which you should remember, right? But instead of remembering this form, we can also use a simple idea of point slope, right? On the basis of which this form is derived. So we can use that as well. I'm okay with any of those approaches. The important thing here is y equals m times x minus h. If you want to apply this, this becomes y is equal to m, which is minus 2 times x minus of minus 3, which becomes this. This is what you'll get, right? And this further simplifies to 2x goes on the left hand side plus y and plus 6 is equal to 0. This is the answer for this particular question, as you can see over here. That's the complete solution for fifth question. The sixth question says, intersecting y-axis at a distance of 2 units above the origin and making an angle of 30 degree with positive direction of x-axis. That's what we are interested in. So let's see. Let's draw the x-axis, y-axis and mark the points. Y-axis at a distance of 2 units above the origin. So this is the point. This is 0, 2. Okay. This is y-intercept is 2, you can see. Angle of 30 degree with a positive direction of x-axis. So this is what we are interested in. This direction is, this angle is 30 degree. So what will be the slope? M equals tan 30 degree. What is that? This is 1 by root 3. And this is a very important form. This is slope intercept form. Y is equal to mx plus c is this form, where slope is equal to m, or m is equal to slope, and c is the y-intercept. C is the y-intercept, right? It can be positive or negative. Right? Here it is positive. Therefore, equation y equals slope 1 by root 3 x plus y-intercept, which is this. This is the answer for this question over here. We can rearrange this as well. This is root 3y is equal to x plus 2 root 3, or it can also be written as x minus root 3y plus 2 root 3 is equal to 0, whichever form you require, right? That's the final form. That's the final answer for this question. The 7th question says passing through the points this and this. Now here you are given 2 points. So we'll use the 2-point form directly. And 2-point form is pretty simple. For example, if you have this x1, y1 and x2, y2 as 2 points on the line, then you can use a simple idea that the equation of line will be y minus y1 upon x minus x1 is equal to slope, which is y2 minus y1 upon x2 minus x1. This can be rearranged as y minus y1 is equal to x2 minus x1 times x minus x1. This can be rearranged as this. This is the equation of line. Right? This is the equation of line passing through points x1, y1 and x2, y2. So if you are given the points, let's say minus 1 comma 1 and 2 comma minus 4. This figure is not up to scale, right? I have not drawn the coordinate axis. I am just marking the 2 points. Equation will be y plus 4 upon x minus 2. Y minus y1 upon x minus x1 is equal to y2 minus y1, which is 1 plus 4 upon minus 1 minus 2. This is what you have, right? 1 minus of minus 4 becomes this, minus 1 minus 2 becomes this, and y plus 4 upon x minus 2. This is what you have. This further implies that y plus 4 is equal to 5 upon minus 3 times x minus 2. Okay, please observe this carefully. This further becomes minus 3y minus 12 is equal to 5x minus 10, and this tells me 5x plus 3y. Let's bring this 3y on this side, and this becomes minus 12. Yes, please check that, minus 12, and this is minus 10. So bring 12 also this side. This is plus 2 is equal to 0. 5x plus 3y plus 2 is equal to 0. Yes, that's the answer for this question over here. The 8th question says perpendicular distance from the origin is 5 units and the angle made by the perpendicular with the positive x-axis is 30 degree. Now here we are talking about the normal form. The normal form is very important, very interesting and slightly typical. The position of the line can be this, and if this is angle alpha, this is perpendicular distance p. Equation will be x cos alpha plus y sin alpha is equal to p. This is the form, right? Now alpha can be in the second quadrant, third quadrant, or in the fourth quadrant as well. P has to be positive, that's the important thing. So perpendicular distance from origin is 5 units and the angle made by the perpendicular with the positive x-axis is 30 degree. This is 30 degree and the perpendicular distance is given to be 5 units. So P and alpha, alpha is 30 degree, it is given. P is equal to 5 is also given. So equation will be x cos alpha plus y sin alpha is equal to P, which is this. What is cos 30 degree equal to? This is equal to x cos 30 degree is root 3 by 2 plus y times 1 by 2 is equal to 5. What is that? Root 3 x plus y is equal to 10. This is the final answer for this question over here. Root 3x plus y equals 10 is the answer for this question. This is 8th question. The 9th question says, vertices of triangle PQR are P, Q and R given like this. Find equation of the median through the vertex R. That's interesting. Interesting. How is it interesting? Because we are supposed to do some manipulation first. Before writing the equation, we are supposed to do some manipulation. Let's draw a figure once again, not to scale, mind you, right? This is vertex P, this is Q, and this is R. Let's say vertex P is 2, 1. This is minus 2, 3, and this is 4, 5. The median through R will be this particular line which passes through midpoint of this. Okay, and joins this. This is the median we are interested in. This is point S. Now S is the midpoint of PQ. This is important, right? So median RS is question mark. This is being asked. And for that, S is midpoint of PQ, that is supposed to be found first. If you find that midpoint, you have one point already known, you found another point, you can easily use the 2-point form to write the equation of median. So midpoint of PQ, since median passes through the midpoint of opposite side, this is what we have. And midpoint of PQ, the coordinates will be x1 plus x2 by 2, y1 plus y2 by 2, where x1, y1 and x2 by 2 are the coordinates of P and Q. 2 minus 2, which is 0 by 2 is 0. 1 plus 3, 4 by 2 is 2. This is what you have. The coordinates of S have been found now. Once you have R and S, points are known. If you know R, which is 4, 5, and you know S, which is 0, 2, you can easily write the equation using is equal to this particular 2-point form of equation of a line, using this particular 2-point form. The equation will be y minus y1, which is 2, is equal to y2 minus y1, 5 minus 2 upon 4 minus 0 times x minus 0. This is what you will need. Right, so this becomes y minus 2 is equal to 3 upon 4 times x, or 4y minus 8 is equal to 3x, which tells me 3x minus 4y plus 8 equal to 0 is the required equation of RS. That's what you need. That's the final answer for this question, as you can see behind me. The 10th question says, find the equation of the line passing through this and perpendicular to the line through the points this and this. Okay. So you're given one particular point on the line and you're given another condition. You needed two conditions, you're given another condition in another way. What is that? How's that? Right? Equation of line passing through this. Minus 3, 5 is a point. Let's say, let's call this point A. Okay. And perpendicular to the line through the points. This is perpendicular to another line through some other points. What are those points? B is 2, 5 and C is minus 3, 6. Let's say this is the case. Right. So if slope of this line can be found m1, the slope of this m2 can easily be found. The condition that we have is, since they are perpendicular, m1 times m2, the product will be equal to minus 1. This is a condition, right? Okay, and what is m1 equal to? Can I find m1 easily? By the way, equation of this line is being asked. Point is known. If the slope becomes known, then we can easily write the equation using point slope form. Yes, pretty simple. And the slope m1 is actually slope of this BC line. What is that equal to? 6 minus 5 y2 minus y1 upon x2 minus 3 minus 2. This is 1 upon minus 5, which is minus 1 upon 5. You can write it as this. This is the slope m1. Therefore, m2 is equal to minus 1 upon m1. Negative reciprocal, you can say. Taking the reciprocal and then multiplying with the minus. Reciprocal will be minus 5 and multiplying with the minus. This will tell me m2 is equal to 5. Pretty interesting, right? Now, once you have found m2 and we are given A, let's draw this diagram. This is point A, which has coordinates minus 3, 5, and this is m2, which is equal to 5. Okay. Once we know these two things, we can easily use the point slope form. What is the point slope form? Point slope form says y minus y1 is equal to m times x minus x1. Let's use this form and get the equation of line. Therefore, y minus y1. What is y1? y1 is 5 is equal to m times x minus x1, x plus 3. This is what you get. This tells me y is equal to 5x plus 15 and 20. This is what will become. Or you can say we'll have 5x minus y plus 20 is equal to 0. That's my answer for this question, as you can see behind me. The 11th question says a line perpendicular to the line segment joining the points this and this divides it in the ratio 1:n. Find the equation of the line. Let's talk about this. Line perpendicular to the line segment joining this and this. Okay, there's a line segment joining 2 points, 1, 0 and 2, 3. Okay, divides it in the ratio 1:n. Okay, so 1:n would be somewhere here, 1:n. Since this point is given before this point, therefore 1:n will be in this particular manner. Right, that's the convention that we use. Right, line divides the join of this and this in the ratio 1:n. Therefore, 1 will be towards this point 1, 0 and n will be towards this point 2, 3 and perpendicular to this line. So we have this kind of a line which is perpendicular to this given line. Okay, find the equation of the line. That's what we are interested in. Okay, the equation of the line can be obtained if we can find this point over here. Let's call this A, let's call this B, let's call this P. Okay, we have slope m1 and we can find slope m2 as well. So that's only one condition. The other condition will be found by using this point, by finding this point, right? And this point can be found by using section formula. So for line, I need two things. I need the point P. The coordinates of point P are very simple. 1 times 2 plus n times this 1 upon 1 plus n. This is m1 x2 plus m2 x1 upon m1 plus n2. Next, 1 times 3 plus n times 0 upon 1 plus n. The x and y coordinates of point P. What is that? N plus 2 upon n plus 1, comma, this is 3 upon n plus 1. Coordinates of point P. Okay, can you also find the slope m1? m1 is slope of this line, which is y2 minus y1 upon x2 minus x1. 3 minus 0, mind you. This is 3 minus 0, 2 minus 1. This is 3 upon 1, which tells me m1 is equal to 3. If you have found m1 easily, can you find m2 as well? m2 is the slope of perpendicular line. So therefore m2 is equal to negative reciprocal of this. This tells me m2 is equal to minus 1 by 3. Now for our required line, what do we have? For finding the equation of that line, we needed two conditions. Point P and slope m2. We have the point and we have the slope. We can easily write the equation using ideas y minus y, using point and slope. This is the concept. This is the idea of point slope form, right? So y minus point y1, this is what you need, is equal to slope minus 1 by 3 times x minus this x1, n plus 2 upon n plus 1, right? Let's not be confused between n and x. Let's multiply by 3. This becomes 3y minus 9 upon n plus 1 is equal to minus x. This is x and minus becomes plus n plus 2 upon n plus 1. Okay. Let's bring this x on this side. This is x plus 3y is equal to, let's bring this term over there, 9 plus n plus 2 upon n plus 1, taking n plus 1 as the LCM, right? X plus 3y is equal to n plus 11 upon n plus 1 is what I get. Leave the equation in this form and then you are good to go. Or you can bring this n plus 1 over here as well. That's all. In whatever form you require. That's the final answer for this question, as you can see behind me. Question 12th says that find the equation of a line that cuts off equal intercepts on the coordinate axis and passes to the point 2, 3. How do we deal with this one? You're given one point, but you're not given anything else. Or are you? Yes. You're given a condition that the line cuts off equal intercepts on the coordinate axis. Now by equal intercepts you mean they're actually equal, that they're equal. If one intercept is +3, the other intercept will also be +3. Now another idea could be that the intercepts are of equal length. Now in case intercepts are of equal length, now 3 and -3 both are same lengths, right? So the idea here, the idea which is important is, since the intercepts are exactly equal, you'll have +3 and +3 like this, or maybe -2 and -2 like this. So these will be the possible cases, right? If you observe, any line having equal intercepts will be parallel to these lines, yes or no? Means the slope of that particular line will be fixed. Yes. So indirectly you are given the slope. Along with this point, you are also given the slope. Mind you, I'll discuss one more condition over here, and what is that? That the line may cut off intercepts of equal length. The line may cut off intercepts of equal length, and in that case, the length can be equal in this way, or the length can be equal in this way also. One intercept will be positive, the other will be negative. So in such cases, line can be parallel to these lines, or line can be parallel to this particular line over here. Right. So the slopes in these cases, what will the slopes be? This particular angle, if you can observe, this is 90 degree and this here is an isosceles triangle. If this is an isosceles triangle, this particular angle can be easily found. If this is 90, the sum of these two is 90, therefore each of these is 45 degree. Therefore this particular angle will be 135 degree, and yes, this will tell me the slope is equal to -1, that's for sure. And if this is the case, then you can observe that the slope of this is -1, whereas the slope of this is 1. Okay, so if intercepts of equal length are cut, then the slope can be +1 or -1. If the intercepts are exactly equal, the person is using that term, equal intercepts, in that case the slope will be -1. Something which you can remember, right? Something which you can memorize. So let's talk about this question over here. Find the equation of a line that cuts off equal intercepts on the coordinate axis and passes through the point 2, 3. So the line passes through the point 2, 3 and cuts off equal intercepts. 2, 3 would be somewhere here. This point is 2, 3. Let's call this point A, and since it cuts off equal intercepts on the coordinate axis, this is what the line will look like. Right, and this particular angle, if it is 45 degree, so this particular angle will be 135 degree from the positive x-axis anti-clockwise. Therefore, slope m will be equal to tan 135 degree, and by this time you should be aware of this particular value, which is -1. So slope has been found, point is already given, equation of line can be written in terms of y minus y1 m times x minus x1, which is the point slope form, which tells me y minus y1 is equal to slope times x minus x1. This is what you have. Yes, can you memorize that? But can you remember? Can you understand that easily? Yes. So let's rearrange this, becomes minus x, which comes over here, x plus y. This is +2, then you have +3, which is equal to 5 on the right hand side. This is the equation of line that I'll get, and yes, that's the answer for this question over here. The 13th question says, find equation of the line passing through the point 2, 2 and cutting off intercepts on the axis whose sum is 9. Okay, intercepts on the axis whose sum is 9. That's interesting. Line is passing through the point 2, 2. And if some of the intercepts is what we are interested in, I would like to discuss about one particular, I will try to pick up one particular form of equation of line. What is that? You remember the intercept form, double intercept form, or the intercept form. If this point is a, 0, x intercept, this point is 0, b, the y intercept, the equation of line becomes x by a plus y by b is equal to 1, where a and b are nothing but the x and y intercepts. X intercept can be positive, negative. Y intercept can be positive or negative. Okay. And in this particular question, it is given equation of the line passing through the point 2, 2. One condition is line passes through 2, 2. The other condition is cutting off intercepts on the axis, whose sum is 9. So it is given that a plus b is equal to Fine. This is given. This is given. And I'll use this form, right? If this is the line and it passes through 2 comma 2, therefore 2 upon A plus 2 upon B. This point 2 comma 2 will satisfy this line, right? So this will be equal to 1. Okay. And I have one condition, I have another condition. Can I get the values of A and B? Yes, I can easily solve these two equations to get the values of A and B. That is what I am interested in for getting the equation of line. Yes, let's solve them. Let's simplify this. This is 2B plus 2A is equal to AB. Okay. 2 times A plus B is equal to AB. Or you can say that the product AB is equal to A plus B is 9. 9 times 2 is 18 is what I get. And A plus B is equal to 9. AB is equal to 18. Solving these two equations simultaneously, equation 1 and equation 2. From 1 and 2, what do we get? Do you observe that A times B can be written as 9 minus A is equal to 18, which tells me minus A square plus 9A is equal to 18, or A square minus 9A plus 18 is equal to 0. This is what you have, right or not? This is what you have. And 18 can be factorized as 6 and 3. This becomes A minus 6. A minus 3 is equal to 0. 6 and 3, the sum is 9. This tells me that A will be equal to 3 or A will be equal to 6. This further tells me B will be equal to 6 or B will be equal to 3. And this further tells me that equation of line will be x by 3 plus y by b, which is 6, is equal to 1, or x by 6 plus y by 3 is equal to 1. Can I take the LCM? Yes, LCM will be 6. So let's multiply by 6 throughout. This tells me 2x plus y is equal to 6, or x plus 2y is equal to 6. Equation of line will be either this or this. That's what we can observe from this complete solution of the question, right? Sum of the intercepts is given to be 9. And I use the intercept form for solving this question over here. Is that all? Yes, that's all in this question. The 14th question says, find equation of the line through the point 0, 2. And making an angle 2 pi by 3 with the positive x-axis. So given angle, you are given point, you can easily find the equation. Also find the equation of line parallel to it crossing the y-axis at a distance 2 units below the origin. So you will find equation of another line, for which slope can be found with the help of this, and you are given the y-intercept in another way. Equation of line passing through 0, 2. 0, 2 is this point. Making an angle of 2 pi by 3 with positive x-axis. Now 2 pi by 3 is greater than 90 degree. So 2 pi by 3 will be this angle over here. Right, positive x-axis, this angle is 2 pi by 3. Okay, this is 0, 2. Therefore this y-intercept is 2. Okay, slope m will be tan theta, which is equal to tan 2 pi by 3. Which is equal to tan 2 pi by 3, tan 120 degree, or you can say tan of pi minus pi by 3. You should be aware of the value by now. This is tan of pi minus pi by 3. Use allied angles and you see this is minus of tan pi by 3, which is minus of root 3. This tells me m is equal to this. Y-intercept c is equal to 2. Equation becomes y is equal to mx plus c. Using this form of slope-intercept form, tells me that y is equal to minus root 3x plus 2, or root 3x plus y is equal to 2. This is my equation, first part. Yes. What about the second part? Also find the equation of line parallel to it. Okay, there is a line parallel to it crossing the y-axis. Crossing the y-axis at a distance of 2 units below the origin. 2 units below the origin will be this, and a line parallel will look like this. Yes. Slope will be same. If this is m, this is also m. And this point is minus 2. Okay. So for this line over here, having y-intercept minus 2 and m is equal to same, minus root 3. Equation will be y is equal to mx plus c. and here C is equal to minus 2. Therefore, equation will be y is equal to minus root 3 minus mx minus 2, that is plus 3, right? And this becomes root 3x plus y, root 3x plus y plus 2 equals 0. And yes, that is the answer of the second part over here. That's the answer of this second part over here, as you can clearly see behind me. This is 14th question for us. The 15th question says, the perpendicular from the origin to a line meets it at the point minus 2 comma 9. Okay, find the equation of the line. That's the question. Perpendicular from the origin to a line. This is interesting. This is interesting. Yes. Let's draw the coordinate axis first of all, since you are interested in origin and the point. Okay, this is origin 0 comma 0, and you need a point minus 2 comma 9. So minus 2 comma 9 would be somewhere here. Let's mark this point over here. And if you observe, the person is saying, okay, this is a perpendicular on some line. If this is a perpendicular on line, so line will be perpendicular to this. Yes. So line will be in this way. Line will be this. This is perpendicular to this point. This point is P, which is minus 2 comma 9. Yes, that's what you can observe. The perpendicular from origin to a line meets it at the point minus 2 comma 9. Find the equation of the line. This is 0 comma 0. If you are interested in the equation of line, you are already given a point. Can you find the slope? Yes. Since if this slope is m1, this slope is m2, you know that m1 times m2 will be equal to minus 1. Yes. And you are also given m2 easily. You can also find m2 easily since the points are given. This is 9 minus 0 over minus 2 minus 0. m2 is equal to minus 9 by 2. Therefore, m1 will be reciprocal and take the negative. 2 by 9 and take the negative. It will become 2 by 9 only. Slope m1 is known, point is known. You are given for this particular thing, you have point P minus 2 comma 9 and you have the slope. M equals, for this particular line you have 2 by 9, right? For that line which is perpendicular, right? Okay, so for that line, equation can be written in terms of point slope form. Y minus y1 is equal to m times x minus x1. This is your point slope form. Let's apply the point slope form to get the equation. Y minus y1 is equal to 2 by 9. X minus or minus 2 will become plus 2. Let's multiply by 9. This becomes 9y minus 81 is equal to 2x plus 4, or 2x minus 9y plus 85 is equal to 0. That's the answer for this question. Okay. Now some of you may think of, on reading this question, okay sir, this is perpendicular. Are we given this length somehow and this angle somehow? If we get that, we can also apply the normal form. Yes, you could. But then, since you are given that point directly, you are not given alpha and p. So, calculating alpha and p will be very complicated over here. If you want, you can try that on your own. Using this approach is pretty simple in this question, as you can see behind me. That's a complete solution for this 15th question for us. The 16th question says, the length L in centimeter of a copper rod is a linear function of its Celsius temperature. Temperature, increasing the temperature increases the length. Expansion on increasing temperature. Yes, expansion and contraction on change of temperature. That's something which you have studied in physics, and there's a question based on that. In an experiment, if L equals this when C equals 20 and L equals this when C equals this, express L in terms of C. It is given, mind you, it is given that it is a linear function. Since the person has said that this is a linear function, L is in centimeter and Celsius temperature C. So we are interested in L and C, a relation between L and C. And since the relation is linear, therefore what you will get is a linear function, that is a straight line. Okay, straight line kind of in this. And on the straight line you are given 2 points. Which axis will be the x-axis? Let's take, okay, we can change the temperature. So let's take temperature as an independent function. On the basis of temperature, the length changes. So let's mark C over here. Let's mark L over here. Okay. C is on the x-axis, so the first point will be 20, comma 124.942. This is point A, let's say. The other point B will be 110, comma 125.134. Now, you have converted that whole problem into this graph now. And you can easily solve this graph because that's what we have been doing for so long, right? We can easily solve and get L in terms of C. Basically, Y in terms of X is what we are interested in. Okay, we are interested in the equation of this line. Yes, we are interested in the equation of this line. You know how to find that. This is 2-point form. Let's apply concepts. Y minus Y1 is equal to 2-point form. This is what you need, right? Instead of Y and X, you get L and C respectively. So therefore, L minus L1, let's use this, 124.942 is equal to Y2 minus Y1, this minus this. Okay, 125.134 minus 124.942 upon x2 minus x1, 110 minus 110 minus 20 times x minus x1, which is x minus 20. This is what I'm getting. Okay, let's simplify this further. This is 90 over here, is it? Yes. So this becomes 90 times L minus 90 times 124.942 is equal to, what is this? 125.134 minus 124.942. Let's subtract them. 4 minus 2 is 2 and 13 minus 4 will be 9, and then you get a 0 over here. 0 minus 9 is difficult, so what you'll do is carry forward this will become this, and this is 0. 0.192 x minus 0.192 times 20 is what I'll be getting over here. This is the equation. Okay, that will not be x, that will be a c over there, right? Let's change that x to c. This is not x, this is c over here. This is c, this is c. Okay, once you make that modification, now let's continue further. So you have express L in terms of c. Oh, you are interested in only L in terms of c, is it? That would be a relatively simpler one. We don't have to multiply this by 90 over here. So we can skip that step. Maybe L equals something. Okay, we can skip this step. So you have L minus 124.942. Let's rewrite it as, this is equal to 90 times this. So 90 will come in the denominator. 0.192 upon 90 times c minus 20. Let's write it as this. And this tells me L equals, pretty simple, L will be equal to, in terms of c, this will be equal to 0.192 upon 90, okay, times c minus 20 plus 124.942. You do not need a relation in x and y, you need L in terms of c, and this is the value that I am getting. This is what I will be having. Right, express L in terms of C, this is what we have, although we can simplify it further by multiplying 0.192 upon 90 into C and multiplying this with 20 and maybe dealing with this one over here, but we can leave the answer at this stage as well. That's the complete solution of this 16th question in front of us. The 17th question says, the owner of a milk store finds that he can sell, again a word problem, real life, kind of related to real life. He can sell 980 liters of milk each week at rupees 14 per liter, okay, and 1220 liters of milk each week at rupees 16 per liter. Assuming a linear relation between selling price and demand, how many liters could he sell weekly at rupees 17 per liter? Let's see. So we have linear relation between selling price and demand, okay. So if it is selling price on this, selling price which can be denoted by S or price for that matter, P, let's denote it by P, okay, and selling price and demand. Let's demand can be denoted by D over here. So finds that he can sell 980 liters of milk each week at rupees 14 per liter. So you have a point 14 price and 980 is the demand. This is what you have. A point is known. Let's mark this point A. Then you have 220 liters of milk each week at rupees 16 per liter. So if you have a point B, this says 16 is the price and corresponding demand will be 1220. Oh, generally it does not happen this way. Generally it happens if the price increases, the demand decreases. But never mind. Let's see. The person further says that if price becomes 17, then what's the demand? Let's talk about D17 or in general D. Let's call this D. This is point C and D is question mark. The relation, as the person has said, is linear. Okay. Assuming a linear relationship, that's what the person has mentioned between selling price and demand. How many liters could he sell weekly at rupees 17 per liter? In mathematics, you have to remain consistent with units. If you please observe, volume is in liters throughout, liters. And price is in rupees, right? So that's pretty simple. What you'll get is demand at the end of the day, the value of D that you'll get will be in liters. So let's focus on that. ABC, can you observe that the points ABC are collinear over here? Yes. So one of the things that you can use is simply concept of slope. M of AB is equal to M of BC and you can get D, right? Another idea could be that you write the equation of line joining A and B, okay, and substitute P is equal to 17. Therefore, you get D, the value of D. Let's use a simpler idea using slope of collinearity. M of AB is equal to M of BC. What is that? M of AB is y2 minus y1, 1220 minus 980 upon 16 minus 14 is equal to BC, D minus 1220 upon 17 minus 16. This is what you have. Y2 minus y1 16 minus 16, similarly here also. So this is 240. This is 14 actually, right? Yes. Upon 2 is equal to D minus 1220 upon 1. Okay. This is 120 over here. So D minus 1220 is given as 120. And this will tell me D is equal to 1340 in liters. That is my required answer. That's the demand. When the price reaches 17 rupees per liter, that's the demand. And that's the answer for this question using linear relationship and the graph, concepts of straight lines in this manner. It's a pretty simple question. Yes. Let's talk about 18th question. PA comma B is the midpoint of a line segment between axes. Show that equation of the line is this: x by A plus y by B is equal to 2. Okay, let's deal with this one. So P is the midpoint of a line segment between axes. Without lots of generality, let's take point P on the first quadrant, right? A and B correspondingly will be this midpoint of a line segment between axes. So let's say this point A and B are the points of intersection of line with the axis, x-axis and y-axis respectively. This is the origin and the midpoint is P. This P, A comma B is the midpoint of this line segment AB now, okay. Show that equation of the line. So we are supposed to find the equation of line. If we can find that, very good. So let's call this point A h comma 0. Let it be h comma 0. Let this be 0 comma k. Can we begin with this? Yes. This here is the midpoint. Yes. So let A h comma 0 and B 0 comma k are the intercepts. Oh, do you remember the equation in terms of both intercepts, right? You remember the equation x by A, or which will become x by h plus y upon B, which is k is equal to 1, is the equation of line actually. This is the equation of line. This is something we remember, right? From the concepts of equation of straight line. Okay, so if I can find h and k, maybe in terms of A and B, because only A and B are given. If I can do that, then I can easily write the equation. Let's try to find h and k. Okay, the midpoint of AB is P. So coordinates of P will be x1 plus x2 by 2, which is h plus 0 by 2, comma, y1 plus y2 by 2, which is 0 plus k by 2. But these coordinates are given as a comma b. Okay, this tells me h by 2 comma k by 2. This is equivalent to a comma b, or you can say h by 2 is equal to a, h equals to a, and k equals to b. This equals this equals this. So you get the value of h, you get the value of k. Therefore, equation of line which is required was x upon h plus y upon k equals 1, which becomes, let's substitute h and k, x by 2a plus y by 2b equals 1, or which can be further, you can multiply by 2, this becomes x by a plus y by b is equal to 1. That's the required answer for this question over here. Mind you, I can solve this directly from here, from this diagram as well. And how can I do that? If I can find this point here only, it is very much possible. So, if I mark this point as h, instead of writing this point as h, let's take a look at this. This is midpoint, right? Imagine this triangle over here. Okay. Imagine this point over here. This is midpoint, and therefore this, if this line is parallel to this will also be the midpoint of this side. Yes. By you have studied triangles, right? And in triangles you have studied something called midpoint theorem. What does it say? If a line is parallel to base, passes through midpoint of one side, it will also pass through the midpoint of other side. Right. This is the base, this is a line which is parallel. If this is the midpoint, this will also be the midpoint. So this is the midpoint A. Okay, this distance is A, and this will also be A, so this will actually be 2a comma 0. Yes, I'll directly write x by 2a. Similarly, if I draw a line which is parallel to the base, this base, and this is the midpoint, therefore this will also be the midpoint, therefore this distance b will imply this distance b, this becomes 0 comma 2b, I'll directly write y upon 2b, that will be equal to 1. Simple approach. Right. In future, you will encounter questions maybe wherein this ratio will not be 1:1, this ratio will be something else. But still, you can apply similar concepts. Right. Basic proportionality theorem comes into the picture. What says that if this ratio is lambda is to, if this ratio is m is to n, this ratio will also be m is to n. This length is known, you can easily find this length and therefore the total length. Yes. If this ratio is m is to n, this ratio will also be m is to n. Using that idea, you can directly write coordinates of A and B. On the basis of that, you can directly reach this stage. Therefore, get the equation of line, right? A shorter, simpler approach can be followed for such questions in future, wherein you write A and B directly. But here, I hope this is also clear. We have found that A and B using that section formula only, right? That only. That's a similar approach, and this question is clear. After this, let's move on to the next one. The 19th question says point R h comma k divides the line segment between the axes in the ratio 1:2. Okay, a similar question. We just mentioned that similar questions, simpler questions could be asked. And yes, a similar question has come in front of us. Divides the line segment between the axes. Okay. So without loss of generality, let's assume that point R lies in the first quadrant. Right? It could lie in the second, third, fourth quadrant as well, but without loss of generality, because it may lie in any quadrant for that matter, equation will be same. Point R divides the line segment between the axes. When the person says between the axes, so between x axis and y axis, x axis comes first, right? So as convention, when you say that this is it, point R divides the line segment joining this A and B, the line segment between the axes in the ratio 1:2. So what will you take? Will you take this as 1, this as 2? As convention, 1:2, this 1 will be towards the x and this will be between the axes, x comes first and y comes second. So this will be towards this and this will be towards this, as conventional. This is as per convention, right? Which convention? The NCERT people talk about that, right? Okay. In an ideal case scenario or in another case scenario, this would have been a typical question, because we'll have to solve both parts maybe. 1:2 and 1:2 in the reverse order as well. Another person may talk about that. But then NCERT people only talk about this particular case, wherein the first one and the second one with x and y respectively. So if you are supposed to find the equation of line and it is given that this ratio is 1:2, can you now identify the coordinates with the help of this parallels? Yes. So this is h. Okay. This ratio is 2:1. So this will be also 2:1. Okay. This is 2 and this is 1. This will become h by 2. Therefore, the coordinates of A will be 3h by 2, comma 0. Oh, what are you doing? I explained the concept in the previous question, right? And now I am dealing with that concept. This height is k, right? This ratio is 1:2. This is k. This ratio is 1:2. So if this is k, this becomes 2k. And the point here becomes 0, 3k. Okay. So equation of line is x by a plus y by b is equal to 1, or which becomes x by a, which is 3h by 2, plus y upon k with b, which is 3k, is equal to 1. This can be further simplified as, in the denominator we have 3, let's multiply by 3, this 2 comes above, this is 2x upon h, 3h plus y upon 3k equals 1. You can leave the answer at this stage, or you can multiply by 3hk and it will become 2kx plus, okay, this becomes hy is equal to 3hk. This is what you get. You write it as this or this or this, both are okay. Yes, let's check that again. You multiply by k, you multiply by h, and you multiply by 3hk. Yes, that's what you have. That's the final answer for this question, as you can see behind me. This question could be solved. In the previous question, we used concepts of section formula, right? Midpoint theorem and all. And similarly, this question can be solved by finding a and b, we can use section formula, right? This can be assumed as something, let us say a, comma 0. This can be 0, comma b, and we write the coordinates of this h, comma k, point r using section formula in terms of a and b. Therefore, we find a and b, which we have done directly over there using basic proportionality theorem of a triangle, right? That's the idea that we have used, and I think that's okay. Yes, that's pretty simple for this 19th question, as you can see behind me. The 20th question says, by using the concept of equation of a line, prove that the 3 points this are collinear. Okay, by using the concept of equation of a line. Now, what does concept of equation of a line say? So if you are given 2 points, you can always find the equation of that particular line passing through those 2 points. Okay, once you find the equation, can you check any other point, whether it lies on that line or not? Yes, you can do that easily. Similar idea that this is point A, let's say, which is 3, 0. This is point B, let us say -2, -2. And this is, let us say, C, 8, 2. So first we'll find, step 1 says, find equation of AB, line AB. Okay, second, check whether C lies on AB, line AB. Those are the 2 steps. Using equation of line. For collinearity, we have other methods. We have already seen that, right? Distance formula, section formula, area of triangle, and slope. Right? We have discussed those things in the first exercise, but right now the person is interested in concept of equation of line. So first, let's find the equation of line AB. Okay, how do we do that? Using formula of 2-point form, y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. That's the formula that we'll use, right? Let's use that formula. What does that give me? Y minus y1, which is plus 2. y2 minus y1, what does that become? 0 plus 2 upon x2 minus x1, which is 3 plus 2 times x1, which is plus 2 over here. This is the equation, right? So what does that give me? This is 5y plus 10 is equal to 2x plus 4, or this tells me 2x minus 5y is equal to 6. This is the line. 2x minus 5y is equal to 6. This is the equation of line AB. Okay. Next step, second step. Check whether C lies on this. So for 8, 2, LHS will be equal to what? LHS will be 2 into 8 minus 5 into 2. What is that? This is 16 minus 10. Okay. And this is equal to 6, which is equal to RHS. Yes, the point C lies on this line. Check whether C lies on line AB. Yes, the point C lies on this line AB. Therefore, the points are collinear. Hence, proved. Therefore, the points are collinear. That's a complete proof of this question using concept of. With this, we come to the conclusion of this interesting exercise number 10.2 from the chapter Straight Line of Mathematics class 11th. Yes. In this exercise, we saw questions based on equation, various forms of the equation of line. And in the next exercise, we'll be dealing with some more interesting things in the conversion between various forms of lines. Till then, next session, all the best.